Hello, everybody. My name is Tyler Wolfe-Driver. I'm one of the three members of the OpenZmeter Data Analytics Integration Project for UTC in the 2023 to 2024 academic year. I just want to start out, go overviewing this tech symposium poster by starting with our motivation. I want to tell the full story of where we started with this project, the roadblocks we encountered, how we got around them, how we found ways to make improvements when it seemed like there wasn't much to do uh, at the time. So, want to start, our original scope for this project was not even including the meter we decided to purchase. It was OpenZmeter was a open source software, and they made meters. They've made many different models ranging from single phase to three phase. And yeah, we were given this meter, or we were given the task to research the capabilities of the meter, and we just had to develop a new function to integrate with the open source software. But we kind of viewed this as an opportunity to tackle a fresh issue. As some of you may know, there was a large wildfire in Maui in 2023 that claimed many lives, cost millions upon millions of dollars in damage, and I'm sure lawsuits that will continue on. And that wildfire was started by transmission line contact with vegetation and high winds. So the motivation for our new feature was to have something of a weather model and a fault event classification system that we could integrate with the software that could tell you this fault type is associated with events known to cause wildfires, and we also have weather patterns that are enabling wildfires, such as dry foliage, high winds sustained for a certain period of time, relative humidity below a certain percentage, and that's the motive. That was the idea. We wanted to do that, uh, and also one thing we really quickly realized that there existed little to no documentation telling you how to go about setting up this meter. How to go about configuring this the Wi-Fi connection for the meter. And we ran into a lot of problems like that. So we quickly, you'll see in the poster that we evolved this scope to create documents to prevent future researchers from going through the same hardships that we had to endure. But I'll move on to the summary for now. So the objectives, like we said, research capabilities of OpenZmeter V3 GPS. It's I would like to call this device more of a prototype because if it were a finished product, you would probably have some instructions that come with it, some, very very well organized documentation. While it's still a incredibly impressive device, that doesn't exist yet. We actually we had to decide between the OpenZmeter models which one we wanted to choose. We went with the V3 GPS. Then we had to decide a new function to integrate with the existing hardware and software, adding value to the product, which I previously described as the wildfire kind of analysis tool. And then we have the last one, which is the one that we focused much of our time on, which is create documentation to fill the large information gaps that regard installation, setup, configuration, and testing with the OpenZmeter V3 GPS. Okay, so um, I'll go right into the project description. There are multiple stages, some of them happening concurrently, one after and others that were happening all at the same time. So uh, we had to, of course, start out with researching the models of the OpenZmeter. We consulted a few industry professionals, both at EPRI and TVA. EPRI being the ones that gave us motivation for our fully defined scope, and TVA being the ones, helping us evaluate the possibility of us completing that scope and also providing some real simulation files of events that the events themselves didn't cause wildfires, but the type of event was known to cause wildfires. So we were able to test those values on the OpenZmeter and get those measurements. And then we had to, of course, research, wildfire analysis, so classification, weather, fault detection. As you'll see throughout this, that's where that's where most of our work was focused for the new feature. It didn't get much further than that, but the next two were the ones we did spend most of our time on, which was to develop the documentation for the initial setup something that previously was non-existent anywhere. This is the first, we've made the first guides for it to help people out in the future. And then testing documentation that was designed so that anyone that has circuit experience could easily take these instructions and replicate our results using the Doble power system simulator, which is actually down here in our figure. And I'll tell you what, let me zoom in. We'll get a closer look at that diagram. So this is your power system simulator. It connects to a computer with the software on it. And then our OpenZmeter circuit, it's taking voltage inputs from the power system simulator, a battery simulator for supplying 125 volts DC. And then we have some current transducers that connect to the current inputs down below. This Schweitzer 735 revenue meter is actually just kind of acting as a terminal, and it's a metered circuit. So it's just that's our current measuring circuit, as you can see. So that's the documentation for that procedure that we developed. So very elaborate process from beginning to end, and it's the first of its kind. So again, trying to help out people in the future, try not to go through the same things that we kind of had to go through setting up. Here's actually a picture of our test subject, Noah, setting up our circuit, putting in the last wire. So testing methods, we had no idea how to use the Doble power system simulator and software, so we had to learn that. We had to figure out how that was supposed to work with our OpenZmeter, and then of course give us a student unfamiliar to metering equipment, and empower our guide and materials to test the effectiveness of our instructions. And we made revisions where we found lack of clarity, confusion, anything that would indicate a spot for us to improve our instructions. So I actually want to go back uh, to over here to our questions real quick. So these three questions are thought-provoking, not only for the person looking at our poster, but also for ourselves, right? These are questions we asked ourselves throughout the scope of the project. First one, what are some of the current issues faced with the OpenZmeter V3? The largest one by far is lack of documentation detailing how to operate the device. And then the limitations to accessibility, that kind of goes hand in hand. There is where there also wasn't any documentation, there is a lack of accessibility, um, it's, especially with Wi-Fi connectivity. One thing that we didn't know, we weren't told at the time, was that we would need to create a static IP for the device itself, because the campus Wi-Fi refreshes IP assignments every 60 minutes, and you can't have this device connected to the internet that way. Otherwise, you won't be able to access the software for it for any other device connected to the same network. Uh, and then the last one, can the device be reliable enough in studies to implement on a larger scale, like at a power utility? If they really wanted to implement not only the meter, but the wildfire tool, we need to test accuracy. That's going to be huge, especially when lives and businesses and large sums of money are at stake in a catastrophe such as a wildfire. This is still kind of open-ended. We haven't been able to compare it, but what we plan to do is compare the measurements made by the OpenZmeter to a much widely more used brand such as Schweitzer, and see if there are accuracy discrepancies between the two. Um, and the main reason that's important is because Schweitzer devices that do the same thing can cost tens of thousands of dollars. This one costs $1,200. So that would be huge if they turns out that the OpenZmeter is indeed very accurate. Some results so far. We created the only existing guide for installing and configuring the OpenZmeter. Also developed a start to finish easy follow set of instructions, as I said earlier, that goes through circuit development, simulating IEEE Comtrade files, and of course then viewing the results in the OpenZmeter. Then this is an open item right now, but by the time of the symposium we will have covered this, is conduct the accuracy comparison between a far more expensive Schweitzer device and the OpenZmeter. And then I kind of want to leave off with this discussion here. So, like we said, the original scope develop and integrate a new feature with the open source software. Many roadblocks required multiple collaborations, not only with the OpenZmeter inventors, but every UTC staff, um, also our faculty sponsors and Dr. Rising and Dr. Foley, campus IT lab assistants to get training on the Doble and understand how a metered circuit works. So those roadblocks kind of prevented us from getting to the stage where it was time to look at the code structures and integrate a feature. We still did the research, but mostly our focus towards the end of this project has been to fill these information gaps so that people that want to make a meaningful change and add a feature that could be so beneficial, such as a wildfire event detection on a power line, they won't have to have the same struggles that we have. So that concludes our project poster, and uh, we will continue to work on this and up until the symposium. So we will likely have some more results and more findings by then.